Now coming on to the problem number 4, it's also geometry. We have a rectangle A, B, C, D with a size of 6 and 13. Now, the problem says we choose a point B on segment AB. It's not a random point, we choose it so the triangle APD is similar to the triangle BBC. This is the condition. B is chosen on AB, not randomly. It was chosen so that APD is similar to this triangle PBC. Now they're asking us to determine the value of PP. Knowing that PP is smaller than AB, because if we can choose it on the right over here, we can choose another one on the left that satisfy the same similarity that we're asked for. Okay, so they want PP is the smaller one, so we can determine its value. Okay, what can we do right now? Similarity. Okay, similarity and lengths. Of course, we're gonna think about ratio of similarity. Now, we all know that we should use the ratio, but do we know how exactly to use it without being on a mistake or something? Let's see. First of all, I will write the 3 ratio even though only 2 will benefit us. And the first one I want to start with is BC. Now, who can tell me which side BC correspond with? Only one side correspond with BC. PC from the triangle PBC must correspond to exactly PD. And the reason for that is that they are both facing a right angle. Alright? So PC must correspond with PD, not AP, not AD, because they are both the largest of each triangle. They both facing the right angle. So we have PC over here and we write PD over here. Next step is, it is also as important as the previous one, PP. PP. In the triangle PPC, which side would it correspond with? Look at the triangle very good before answering. Yep, it should correspond with AD. Now, some of you may say, wait, no, AD must correspond with BC. No, that's the wrong answer. BC does not correspond with AD, as they, even though they are looking like they are facing each other or not adjacent like those two, I don't care. What really does matter that AD must go with PP and BC must go with AB. Also, if we ever correspond BC to AD, like we write BC and AD on the same fraction, this will be a huge mistake, as we know that BC equals to AD, BC equal to AD, which will make the ratio 1, and this will make the triangle congruent. They did not say congruent, they did say similar. So we just analyze it a little bit and we find out soon that PP is the one to correspond with AD and BC must correspond with AP. Right? So always when you write the ratio of similarity, use your side, not only what you memorize, not only what you can remember. Use your sight, use the analysis view, alright? Okay, now which one did we say that we won't need? Yes, the first one, we do not need this, as we are all working on the side, working on BP, AB, and BCAD. So for this, let's substitute with the values that we already knew. PP is PP. Yeah, is the variable we need to evaluate in the first place. AD is 6, that's good. BC is also 6. AB, I won't try just AB. It's AB, but it's not a new variable. If I know PP, I would know AB. But how are they related exactly? Their sum is 13. So AB, I will write 13 minus BB. That's how you do it. Okay. ما بس هذا القسم بقطع. So this is how you do it. Okay. Now for the ease of writing, I will put instead of PP X. Alright? 6 on 13 minus X. Now, such an equation is just really a simple algebra. Right? We know that this will okay, we know this equation is, as we know, is just simple algebra. So x multiplied by 13 lost. Okay, so this is how you do it. Now I substituted PP with an x just for the ease of writing. X on 6 equal to 6 over 13 minus x. Now, as we all know in simple algebraic methods, that x multiplied by 13 minus x equal to 36. Now it seems like a quadratic equation. That's correct. That's correct. Just we need to maneuver it a little bit. Yeah, still need some maneuvering. Okay, so this is 36. Now, as we have a quadratic equation, we have a different way to solve such an equation, right? One of the methods that I use is guessing. Yes, I do guess. I guess, and probably I did guess from over here, that the answer is 4, 9, 4, 9, as these two numbers add up to 13 and the multiplied is 36, which is correct. I got x could be 4 or 9. In both cases, I have a solution, right? The other method that I could use is delta way. So if I don't want to guess, is there a way for me to find the value of x1 and x2, the two solutions of the equation? If I don't want to guess 4 and 9. Okay, I guessed it and that's good, but is there any other way other than guessing? Yes, there is. Yes, there is. It's the delta way, or having a full square, having a full. Both of the ways we will discuss in later session. I show you that because they are very important to know for sure how to solve a quadratic equation. Okay. Now, as I said, x could be 4 or 9. We have two values. He asked for one. Which one will I choose, 4 or 9? Of course, he asked for the smallest value that I have. If I chose PP to be 9, AB will be only 4, which makes PP the largest. That is not acceptable. So x equal to 4. And it's done. Now we are at number 5. As we saw in number 4, how easy it was to use similarity ratio, how to use it properly. Okay. Yes. Yeah, as we've seen in problem number 4, that how easy it was to use the similarity ratio, how to use it properly, not to confuse it, alright, and how easy it was to solve a problem using similarity if we knew the similarity would be used, okay? No fear of using similarity at all, okay? Now, let's go to number 5, which has a different side of the problems before. It's also about calculating an area of a certain part of a figure, okay? Now let's talk about the figure we have over here. It has a square with a side of 14, alright? A square with a side of 14 and another square of a side that I don't know, okay? 14 and other square adjacent to the first one, okay? Adjacent to the first one. Now, we match this diagonal and we match this point with this point, and we match also from this vertex to this vertex. We have now a triangle that they colored in black, okay? And only giving that this side is 14, they ask for the area of this triangle. How can we possibly know the area of this triangle? Okay, think about it very well. Think about it. Yes. Now, there is a way for me to do this in a slow manner, in a way that I indicate and align variables such as x over here and a over here and c as a third variable for which for the side of the second square. Okay? That's a way that I believe will lead me to the right solution. That I believe will lead me to the right solution. Okay? How? This is x, this is 14 minus x. The side now is a plus x plus 14, so it is a plus 14. So there is only two variables, okay? And I have a plus 14. I have talus. I have talus or parallel lines. I assure you, they will give me some kind of ratio that connects a to x and help me then evaluate the area of the wanted triangle. Okay, I believe that I can lead to there. Okay, this is very good for me. Now I'm on a level that I know that is easy to reach the solution. That's what helps me to think of different way to solve such a problem. A different and a magical kind of way to solve such a problem. Especially in this kind of contest where you have a multiple choices. This problem is brought to you from an competition with multiple choices under each problem. And also that will help me to think in a magical way. Now, what's the magical way I'm talking about? The magical way is like this. Didn't you notice that only I know the side of one of the triangle? Yes? And the other square, the first square, and the other square, I don't know the side, the length of the side. So basically, I can make it very, very large. I can make the length of the side million. Okay? And still, they're asking me to find this area that is related to this vertex of this square. So it's kind of weird, right? If I make it very, very large, the area will still the same? Yes, it will still the same. Yeah. And I will use that for my benefit. I won't draw it millions. No, I won't draw it that large. I will draw it in a suitable way, in a way that suits me. What do I mean by that? I mean this. Since the area is gonna be the same, whatever square I drew, I will draw a very nice square. A square of 14. I will draw a square of 14. Why not? Why not? The area must still be the same. Okay, now which area are they asking for? This. To this, to this, to this. That's the black area they're asking for, only this time very nicer, right? Who can tell me what is the area of this black part of the figure? Right? Right? I have a base, I have an attitude. Now, all I need to do is 14 multiplied by 14 over 2, which equal to 98. And it's over. Now, you can do a talus, you can do similarity ratio. Of course you can do. You can see it over here. We have only two variables. We have a relationship that connects these two variables. So I can figure out something to help me evaluate the area of this triangle. But it would take much time, which may I not have, okay? Especially in such competition, I repeat, which have multiple choices and a lot of problems, okay? Okay, and just so you know, the area of the black bar could be divided into two sections. The first section is this base multiplied by the attitude, which means x multiplied by a plus 14. This is the first part. The second part is x multiplied by 14. So in total it is x multiplied by a plus 28. X multiplied by a plus 28. And I assure you, you will find exactly what you need when you use the similarity ratio. I assure you. Because if you cannot find out what you want in the similarity ratio, then the problem is not correct. The problem has something wrong in it. Because this is the only information that you can get from such a figure. Alright? So if the only information won't give you what you want, so the problem is not correct. Alright? The problem is missing from something and it's not your fault. Okay? And hope you liked the magical way, because it's the way preferred in such a competition.